Hey everyone, welcome back to the channel. Before we dive into today's uplifting environmental story, let me take a moment to send some positive vibes your way. To all of you watching right now, wherever you are in the world, I truly hope you're feeling healthy, happy, and full of energy. May your days be filled with good health and wonderful moments. Now, get ready for some genuinely good news about our planet. The ozone layer is slowly healing. That's right, after decades of alarming reports about the growing hole in Earth's protective ozone shield, scientists are now observing clear signs of recovery. This remarkable environmental comeback story proves that when humanity recognizes a problem and takes collective action, we can actually reverse environmental damage. Let's explore how this healing is happening, why it matters so much, and what lessons we can learn from this global success story. The ozone layer is like Earth's natural sunscreen, a fragile shield of gas in the stratosphere, about 15 to 35 kilometers above the Earth's surface, that protects all life from the sun's harmful ultraviolet radiation. This layer contains high concentrations of ozone molecules, O3, which absorb 97 to 99% of the medium-frequency ultraviolet light that would otherwise damage exposed life forms. Without this protective barrier, more UV radiation would reach Earth's surface, causing higher rates of skin cancer, cataracts, immune system suppression in animals and humans, and severe harm to terrestrial and aquatic ecosystems. In the 1970s and 1980s, scientists made the alarming discovery that certain man-made chemicals were destroying this vital protective layer, creating what became known as the ozone hole over Antarctica. The situation seemed dire, but today, thanks to unprecedented global cooperation, we're seeing measurable recovery, a rare environmental victory in an age of climate anxiety. The discovery of ozone depletion came from an unlikely place, a research station in Antarctica. In 1985, British scientists Joseph Farman, Brian Gardiner, and Jonathan Shanklin published shocking data showing that ozone levels over Halley Research Station had been dropping dramatically each Antarctic spring. Their findings confirmed what other researchers had suspected, that chlorofluorocarbons, CFCs, chemicals widely used in refrigerators, air conditioners, aerosol sprays, and industrial cleaning solvents, were rising into the stratosphere and destroying ozone molecules. One chlorine atom from a CFC molecule can destroy over 100,000 ozone molecules before being removed from the stratosphere. The situation was particularly severe over Antarctica because of unique atmospheric conditions that created an ozone hole each spring, an area where ozone concentrations dropped dangerously low. This discovery sparked global alarm and led to one of the most successful environmental treaties in history. The world's response to the ozone crisis was swift and decisive. Just 2 years after the Antarctic discovery, in 1987, nations adopted the Montreal Protocol on Substances that Deplete the Ozone Layer. This groundbreaking agreement phased out the production of numerous substances responsible for ozone depletion, initially targeting CFCs and later including other harmful chemicals like halons and carbon tetrachloride. What made the Montreal Protocol uniquely effective was its flexible, science-based approach that allowed for adjustments as new information emerged. Its provisions for financial assistance to help developing countries transition away from ozone-depleting substances, and its near-universal adoption. Every United Nations member state has ratified it. Industry played a crucial role too, developing alternative chemicals that performed the same functions without damaging the ozone layer. This global cooperation created a framework that environmental agreements since then have tried to emulate. Now, decades later, we're seeing the fruits of these efforts. According to scientific assessments, the ozone layer has been recovering at a rate of 1 to 3% per decade since 2000. The most recent comprehensive assessment by the United Nations Environment Programme and World Meteorological Organization shows that parts of the ozone layer have recovered at a rate of 1 to 3% per decade since 2000. At projected rates, the northern hemisphere and mid-latitude ozone is expected to completely recover by the 2030s, followed by the southern hemisphere in the 2050s and the polar regions by 2060. Satellite measurements confirm that levels of ozone-depleting substances in the atmosphere are declining, with concentrations of some key CFCs dropping faster than expected. The Antarctic ozone hole, while still appearing each spring, is smaller and forms later in the season than it did at its peak in the 1990s and early 2000s. These improvements are directly attributable to the Montreal Protocol's controls on ozone-depleting substances. The healing ozone layer provides multiple benefits beyond just UV protection. Because many ozone-depleting substances are also potent greenhouse gases, their phase-out has significantly slowed climate change. The Montreal Protocol has actually done more to reduce greenhouse gas emissions than any other international agreement, avoiding an estimated 0.5 to 1 degree Celsius of global warming by 2050. This unexpected climate benefit shows how solving one environmental problem can help address others. The protocol's success also demonstrates that binding international environmental agreements can work when they include clear targets, flexible mechanisms for improvement, and support for compliance. Perhaps most importantly, the ozone recovery story provides hope that humanity can come together to solve global environmental crises when the science is clear and the political will exists. However, the work isn't completely finished. Scientists continue to monitor the ozone layer closely for any unexpected changes or new threats. Some challenges remain, including the proper disposal of existing equipment containing CFCs, like old refrigerators and air conditioners, preventing illegal production and trade of banned substances, and addressing unexpected increases in emissions of some replacement chemicals that, while safer for the ozone layer, are potent greenhouse gases. The recent detection of unexpected CFC-11 emissions from eastern China shows that continued vigilance and enforcement are necessary. Additionally, climate change itself may affect ozone recovery by altering atmospheric circulation patterns, particularly over the poles. These challenges remind us that environmental protection requires ongoing commitment even after initial successes. The ozone layer's recovery holds important lessons for addressing other global environmental problems, especially climate change. It shows that when faced with clear scientific evidence, the world can unite behind science-based solutions. It demonstrates that industries can innovate to replace harmful products with safer alternatives when given clear signals and timelines. It proves that environmental regulations can work without crippling economies. In fact, the transition away from CFCs spawned new industries and technologies. Perhaps most encouragingly, it provides a concrete example of how humanity can successfully reverse environmental damage when we act decisively and cooperatively. As we face the even more complex challenge of climate change, the ozone success story offers both inspiration and a potential model for effective global action. Looking ahead, the continued healing of the ozone layer will have tangible benefits for human health and ecosystems. As ozone levels recover, we can expect reduced rates of skin cancer and cataracts, less damage to agricultural crops sensitive to UV radiation, and protection for phytoplankton at the base of the marine food chain. The Montreal Protocol continues to evolve, with the 2016 Kigali Amendment phasing down hydrofluorocarbons, HFCs, climate-warming gases that replaced CFCs, but turned out to have their own environmental problems. This adjustment shows how the agreement remains responsive to new scientific understanding, setting an example for how environmental governance should work. The ozone layer's recovery is happening quietly above our heads, mostly unnoticed in our daily lives. Unlike some environmental problems where we can see immediate local improvements from our actions, the ozone layer heals gradually across the entire planet. But make no mistake, this is one of humanity's greatest environmental success stories. It shows that global environmental problems can have global solutions when nations, industries, scientists, and citizens work together toward a common goal. As we continue facing urgent environmental challenges, let the ozone layer's recovery remind us that positive change is possible, that science-based policy works, and that our collective actions today can heal the planet for future generations. Thanks for joining me to celebrate this environmental victory. Let's carry these lessons forward as we work to solve other pressing ecological challenges. Stay hopeful, stay engaged, and I'll see you in the next adventure.